All right, so this is our geometry 1 through 60 review, probably part 1. We'll see how much of it we get covered today. We're going to go through kind of questions that you want to cover, but a lot of these will be on the test. So I'll try to do as good a job as I can of kind of letting you know what you need to be able to show on the test in order to actually get credit. Just knowing the answer is not going to be enough. Let's see. So we have a parallelogram. It's labeled LMNO, and it says this is a rhombus. It is not a square. Okay, so which of the following is true? So what I would probably do here is I would draw something that looks like a rhombus and something that looks like a square and try to decipher the differences between those two things. Now, if I'm drawing a picture, right, I've got my rhombus, I've got my square. I have to know some things about rhombuses, and I have to know some things about squares to go about labeling this, right? How should I start? Anybody? You could list the properties. Let's maybe start a little closer to home here. What about the letters? Can I put the letters on? Okay. So L, M, N, O, L, M, N, O. Okay. What makes a square a square? 4 right angles. 4 right angles would be what we would be looking for here. Okay. That's all of that does is it makes that a rectangle. Okay. I need another bit of information before I can say that that's a square. The diagonals would be congruent. That still only makes it a rectangle. What else? What else do we know about squares? So it's kind of an obvious thing. We know something about their angles. Do we know anything about their sides? All 4 sides are congruent. Okay? So we get something that looks like that. Correct? Okay? What do we know about a rhombus? What do you know about the sides of a rhombus? The sides are parallel, yes. They're congruent. Okay, we know that these are congruent, just like the square. Okay, because both of these things are parallelograms, they're going to have some things that are common. Okay, does that make sense? Okay, what we want to be able to prove is that our rhombus is going to have some properties that a square doesn't. Okay? All right, so let's look at this. This says measure angle O is 90 degrees. Does that make it a rhombus? What does that make it? All right, so that's a property of a square. We want a rhombus. This says that LN is perpendicular to MO. Is that true of rhombuses? Okay, so I can draw a line across here, I can draw a line across there, and that's going to be a right angle. Okay? Let's see, so that's a property of rhombuses. It's a property of squares, but it doesn't make it a square. Does that make sense? So let's look at the other properties. Angle L is congruent to angle M. Angle L is congruent to angle M. Would that be true of a square? But it wouldn't be true of a rhombus. Okay, so this again, this is a square. Okay, because consecutive angles in a rhombus are not congruent. Not necessarily. Okay, does that make sense? All we know in a rhombus is that consecutive angles are supplementary, meaning they add up to 90 degrees, but they don't have to be equal to each other. This says that LN is congruent to MO, all right? And that's what you said earlier about the square, is that the diagonals were congruent to each other, right? Well, that's a square. Over here, these lengths from LN to MO are not necessarily the same length. You follow me? So the property that we want to use is that the diagonals are perpendicular. Okay? Okay. So if anything, I mean, I would probably draw the picture and I would maybe even label the different properties. That's going to be true of a square. That's going to be true of a square. That's going to be true of a square, right? I want something that's unique to a rhombus. Okay? Now, here's the truth, is that a square is a rhombus. Okay? A square is a rhombus and a rectangle. So this is also true over here, but the reason that we use LN is perpendicular to MO is because that is a shared trait between squares and rhombuses. That's the overlap. Okay? These other properties, those are unique to squares. Rhombuses typically, right, they're going to have a unique shape to them. Okay? I don't know if that helps you out all or not. I've been out of like the game for like 2.5 weeks, it feels like. So if I'm doing a poor job of explaining something, let me know. I'll try to do better. All right. Let's see. Let's come on to question number 2. It's kind of a question that we've seen before, right? Do we need any help with number 2? Yes or no? You guys are abundantly quiet this morning. Help me out here. What do we need? Do we need this? I'm getting a lot of head shaking. No. Okay, we'll move on. 3, you guys tell me nobody missed. 4, you tell me nobody missed. 5, is 5 one we need to look at? Okay, I'm getting a head shake. Yes. A landscape architect is designing a garden in the shape of a regular pentagon. Regular pentagon. So let's start there. Okay. What does it mean for a shape to be regular? Does it mean it goes to the bathroom the same time every day? It was a joke. Nobody laughed. All sides and angles are equal. Okay. The other part, though, says pentagon, so not a square. Okay. A square would be an example of a regular quadrilateral. Okay. Does that make sense? So we want to draw something that's, we know the rules to it. Even if we don't draw it exactly perfectly, we know that the side lengths are all the same length. We know that the interior angles are all the same. Does that make sense? Okay. The side length of the garden measures 3 inches on a blueprint with a scale of 1 inch to 5 feet. How many feet of fencing will be needed to surround the garden? When we're talking about surrounding a garden, are we talking about area or are we talking about perimeter? Perimeter, and that's important because scale, the ratio of the scale stays the same between perimeter and side-to-side length. Okay? So we can set up a proportion. Okay, the side length of the garden measures 3 inches. We have to decide how we want to set this up. So if I want to set up blueprint, okay, blueprint side over blueprint perimeter, we can do that. Okay, and then we would have to do, garden side to garden perimeter. Does that make sense? That's not the only way to set it up, but if we're going to set it up, let's kind of start here. The side length of the garden measures 3 inches. So I put 3 there, okay, on a blueprint with a scale of 1 to 5. Okay, 1 inch equals 5 feet. Okay? So if on the blueprint, that side is 3 inches, okay, what is the number of feet? Let's see, I might be struggling here a little bit. Our scale is 1 to 5, okay, and we know that we have 3, we should be able to find out, okay, how many feet are being represented as a side. Okay, what's 3 times 5? 15 divided by 1. All right, so that means that the actual garden itself would have a length or a side length of 15 feet if it was 3 inches here in the blueprint. Do you follow me? Okay. So it says how many feet of fencing will be needed to surround the garden? Well, what am I going to do? Jordan, what would I do? How would I find out how much fence I need? 15 times 5. Okay. Is that, I want to say 60, but I don't know if that's 75. Not quite. 75, and what's my label here? Is it inches? Feet. Okay, does that make sense? Okay, so let's see if we can finish our proportion out down here. If my blueprint side is 3 inches, okay, then the blueprint perimeter represents 15 feet. Okay, let's see. Well, really it would be the garden side, so let me change that a little bit. That would be 15 feet here, right? Okay, and the blueprint perimeter, that would be 3 times 5, right? 3 times 5 would be, am I messing this up? How bad am I doing here? Let's see, the garden side is 15 feet. Okay, the blueprint perimeter is 15 inches. I don't know, 15 times 15 divided by 3? What does that come out to? Does that come out to 75? That would be great if it did. Okay, you get 225 divided by 3. Oh, you get 75. So I'm not saying that this is the best way. I would probably just go about it kind of the common sense way of kind of drawing the picture, and I would have this proportion up here, and then just take my 15 times 5. Does that help? Okay. So I'm not trying to go out of my way to confuse you. Okay, you guys listed 6 and 7. Nobody missed those, at least not in this class. Okay, let's look at question number 8. Okay, it says a rectangular bookcase shown below has braces placed diagonally across the back. Determine the length in feet of the brace that will be used to create diagonal WY. Okay, means that there's a board across the back that goes from there to there. Okay, what's the typical shape of a bookcase? A rectangle. Okay, what do we know about the angles of rectangles? They're all what? 90 degrees. So could I put a little 90-degree angle back there? Now what shape have I made? I made a triangle. Specifically what kind of triangle? A right triangle. And can we solve for the side lengths of a right triangle? Using which is a squared plus b squared equals c squared. Pythagorean theorem. What would I use for a squared? Chase. 10. So we got 10 squared plus, what would you use for your b squared? Good, 24. Okay, and we're looking for that c squared. 10 squared is what, Cassie? 100. 24 squared is what, Allison? 576. Okay. 100 plus 576 is what, Jordan? 676. What do I do to solve, Bella? Square root it. Very good. Square root 676. Okay, what do I get in my calculator there? 26? 26. Comes out evenly. Okay, so C equals 26. We want to use a label. So 26 feet is my answer, which makes sense because it's longer than 24. Okay, makes it the longest side. All right. All right. We can come down to number 9. It says find the perimeter in inches of the triangle to the nearest 100th foot. What type of triangle is that? 45, 45, 90 triangle. Okay, because there's a 90 and a 45, 90 and 45 is 135. There's 180 degrees in a triangle. Would it be impossible to determine that that's going to be 45? No, not really. Okay. Do we know the properties of 45, 45, 90 triangles? Hopefully. Can anybody tell me what the length of this side is? Nope. Okay, so let's come to our reference triangle. Okay, and you're working the right way, Bella. You're trying to use your reference side lengths. In a reference triangle, what is the length of a side opposite of 45? X. And then the other one is X. Okay, and then what do I have for my hypotenuse, Bella? X radical 2. Okay, very good. Okay, so what we're seeing is that opposite this 45 is 4. So what is opposite that 45? 4. Okay? All right? Because X is equal to 4. Does that make sense? We can follow that? Okay? So if X is equal to 4, then X is equal to 4. Right? So now we have to find out then what is X radical 2. Well, all I have to do is sub in what? 4 for X. So I get 4 and 4 and 4 radical 2. Can we follow that? Okay, now this says what is the perimeter to the nearest 100th foot? Okay. Okay, so this is where we use our calculator, right? Because it wants it as a decimal, we're going to write 4 plus 4 plus 4 radical 2 in our calculators and get an answer. Let's see what we get. We get 4 plus 4 plus 4, second, square root 2, hit enter. We want it to the nearest 100th. What do we get? 13.6 what? 6. Because there's a 5, but then there's a 6 behind that 5, so that moves that 5 up to a 6. And we want to finish off our label with feet, and because it's perimeter, it's not squared, it's just a length. Okay? 13.66 feet. Okay. Do we have this figured out? Some of this making any sense? Are we learning anything today? Just getting warmed up. Okay. All right. Let's see, we have listed number 10 as nobody having missed it, so we'll move past it. Look at question 11. All right. The lesson that we're taught here is that whenever I have multiple parallel lines cut by transversals, that those transversals being divided by those parallel lines are divided proportionally, meaning that I could set up a proportion of 2x plus 1, place it over x plus 5, and that would be equal to the sides opposite of 6 over 6. Does that make sense? Okay. So at this point, there's a couple things that we could determine here. Notice that 6 is equal to 6, right? So what we might be able to find out in the end is that 2x plus 1 is actually equal to x plus 5, right? But let's go ahead and try it this way. This would be the harder way of solving this. I would distribute this 6 to the x plus 5, would solve like a normal proportion. That would give me 6x plus 30 is going to be equal to 12x plus 6. Because I'm distributing the same thing to both values, I could even factor out a 6 out of everything, and that would get me back to 2x plus 1 is equal to x plus 5, right? But we can keep moving here. I would subtract 6x, okay, and I would subtract 6. 30 minus 6 is 24. 12x minus 6x is 6x. Divide by 6. Divide by 6. And we find that x is equal to 4. X is equal to 4. Now it says in the diagram below, this wants me to find AC. So is it enough to find the value of x? No, it's not. And it might be the reason some of us miss this question. I don't know. But it is one of the reasons that most students would miss this question or many like questions on the test is that we solve for x because we're kind of trained mentally to solve for x and not to go any further than that. What we need to do is say that 2 times 4 plus 1 equals, meaning what is AC? 2 times 4 is 8. 8 plus 1 is 9. 9 is the answer, not 4. How are we doing? Okay. Anybody get caught by the x equals 4 trap? Yeah? Some no, some yes. All right. Let's see, it appears that I'm told nobody missed 12. So let's come to 13. We've actually seen this very question before. We want to find the length of BD. Can I ask you a question real quick? Does anybody know what the relationship is between the segment BC and the segment CD? They are congruent. So BD is equal to BC plus CD, right? Okay. Can anybody tell me what the radius of that circle is? 10. Okay, because from A to C, the length is 6, and from C to F, the length is 4. 4 does not represent the length of CD. Okay, does that make sense? All right, so what I'm going to do then, and what you've seen done, is to go ahead and draw a radius line. Now, if we've already stated that the length from A to C is 6 and C to F is 4, and we add up those lengths to find the radius of 10, then what is the length of AD? 10, because the radius is the radius everywhere it's drawn. Now, I have a right triangle, and I could have drawn it the other side. I could have made this line go over here, right, just as easily, okay? Keeping my eye on Jeffrey back there. Hold on a second, I'll be back. All right, buddy. There's getting to be more of them. Let's see. Hold you right there. Let you join your little friends. There you go. And now back to work. Okay, so from here it's really just a matter of the Pythagorean theorem, but there's a couple of steps involved, right? So we know that we're going to have 6 squared plus b squared equals 10 squared, right? We're not getting confused with where the 10 goes, right? We know it's the hypotenuse. 6 squared is 36. B squared is B squared. 10 squared is 100. Subtract 36 from 100. What do we get? All right, so B squared equals 64. Okay, square root of 64. B is what? 8. So this length here, CD, is 8. A lot of people stop there and say, well, BD is 8. BD is not 8. BD is 8 times 2. All right, give me a second here. Okay, so what is the length of BD then? 16. 16. So BD equals 16. Okay? So don't stop short. Most of you are doing really great work. You're getting 90% of the work that you need to get the answer, and then you stop one step short of being able to get what it is that you need out of it. Okay? So be careful with these things. Again, these are all questions that you've seen before. What we should see happening is this test, our grade should be going up the more familiar these questions become to us, correct? Okay? So our expectation is that we not continue to make the same mistakes that we made, say, on this question the last time we saw it. All right. Let's see. That was 13. 14. We've seen ones like this before. Plans for a new community include a rectangular park. It's got a perimeter of 720 feet. Dion creates a model so that the similarity ratio of the park is 1 to 400. What is the perimeter of the model in inches? Okay. So the problem that we had with this question last time is that we got our answer in feet. Okay, and you're still going to get your answer in feet. So if it's 1 over 400, where do I put the 720 at? Does it go on the top or does it go on the bottom? Where does it go? Top, bottom. What do we think? Rectangular park, it's got a perimeter, the perimeter of 720 feet. He creates a similarity ratio of the model to the park. The model to the park is 1 to 400. So what does the 1 actually represent? The model. This represents the park, right? So where would the perimeter of the model go on the other side? The top, okay? We'd leave that with an X, and the 720 would go where? On the bottom. And what's my label going to come out to from this? It's going to be in feet. The answer is going to be in feet. So we're getting, you know, 1, well, let's see. Yeah. 1 times 720 is 720, and then I'm going to divide 720 by 400, right? What's 720 divided by 400? 1.8. All right. So we get X is 1.8, but this is in feet. We want inches. Okay? What do I need to do with 1.8? How do I get it into inches? Times 12, because there's 12 inches in a foot. Okay? So what is the perimeter of the model in inches? What's 1.8 times 12? 21.6? 21.6 feet. Or sorry, inches. Inches. Okay, 21.6 inches. Now, is that the answer in the answer key? Did we get it right? Yes? Okay. All right, but do we understand how to set it up now so that we don't make that mistake? We're not just trying to memorize the word, but understand it. Okay. Okay. Let's move up to 14. 14 says find the angle measures of ACDB. All right. Let me see here. Okay, so there's some ways to look at this. Okay, the fact that it's a trapezoidal shape, is that helpful here? You think so? Well, we do know this, or at least it should work out. Consecutive angles in quadrilaterals are what? Supplementary. So what are consecutive angles here? What angles represent consecutive angles? C and D, okay? C and D and C and A, right? All right, so we could go through there that way, and we could say that, do you want to use C and D or C and A? C and A, okay. So we could say 4x minus 10 plus 2x plus 3 has to equal what? No, not D. 180, okay. Combine like terms, 4x and 2x is 6x. Negative 10 and 3 is negative 7 equals 180. What's next? What would you do now, Jordan? Add 7 to 180. Okay, so 6x equals 187. Okay. Okay, so what do I do now? Divide by 6. X equals what? 31.2. Okay. And let's do some testing here. So that would mean that C is 4 times 31.2 minus 10. Give me 114.8 degrees. What's the answer for C in our answer key? 126. So we did something wrong, right? Okay. Well, that's fine. We learned something here, right? Yes. Okay. Mistakes are not things to be shied away from. I do know this. Does appear, says find angle measures. It appears that this line right here is a diameter, right? Which means that all of this is 180 degrees. Okay. I'm trying to see if there's anything more helpful in here. And we said, let's see, what would be 2 times 31.2 plus 3 plus 114.8 would be 180.2. So I don't know that our answer was wrong, but maybe our estimation was wrong. Because C and A is off by 0.2. So something's not quite adding up exactly the way that it should there. Tell me what you got. When you plugged it in, you got 31.1666666. Yeah, I'm going to say that estimation is going to take us out wrong a little bit. And let's see if we get the same thing when we do CA. You know, we take 4x minus 10 plus 2x plus 3 equals 180. That's going to give you, huh? Is that the one we did? Let's try CD then, sorry. Well, I know we're running low on time. plus 3x plus 7 equals 180. That would be what, 7x minus 3 plus 3. 7x equals 183. Do we get the same thing? 183 divided by 7. There we get x is, what, 26.14. So the question then becomes this. Are consecutive angles in all quadrilaterals supplementary, or is that true only of parallelograms? Might only be true of parallelograms. All right. Let's pause here for a second, and we may even have to stop there.